So hello everyone and welcome to another problem 7 session on Special Maths Academy. So in today's video we are going to cover two problems that occurred in the just concluded Senior Mathematics First Round Olympiad 2020. That's problems 8 and problems 11. So we'll start off problem 8. The question goes like this. For all positive numbers x, y and z, the product this equals to what? So this is just like a question that is based on how familiar we are with the laws of indices. So I'm just going to express each and every one of these four terms to be multiplied. We're going to remove all these power ones from them and express them in the best possible form before we do our multiplication. Because right now it's difficult to multiply at first. So this term x plus y plus z inverse is just going to be 1 over the base of the minus 1. And this x inverse plus y inverse plus z inverse, just add the inverses up. And from here, we find the LCM of the three numbers, or the common multiple of three numbers, not necessarily the LCM. So that gives us yz plus xy plus x plus zx plus xy. So actually, it doesn't really matter the order I wrote it, but I just wanted to do this because that's how it's arranged. Then this third term to be multiplied. The inverse of this, by laws of indices, is just 1 over the number, the base of the power, yz plus zx. And the last one, xy inverse plus yz inverse plus zx inverse. As we all know, it should be this. So we can find the common multiple. We have this. So what's left for us now to do is to multiply these terms now. I'm putting in red boxes. 1, 2, 3, 4. So they are much easier to multiply than what was given to us in the original question. So when we multiply all of them out, we are going to get 1 over x plus y plus z times yz plus zx plus xy all over xyz times 1 over xy plus yz plus zx multiplied by z plus x plus y all over xyz. So as you can see, a lot of things reoccur, and some occur once at the numerator and occur also at the denominator. So instances like that can make us to cancel out some things. So if you notice here, yz plus zx plus xy occurs on numerator here and denominator here. It doesn't really matter the order which the terms are written. Addition is commutative, so because all the three terms are there, they are both equal. So these two cancel out. And similarly, these two cancel out. So we'll be left with this and this. But since they are on the same side of they are both on the denominators, they can't cancel out. So our final answer will be 1 over xyz squared. I want to check our option. There's no option that is explicitly written like this. So we have to start manipulating this, and this by laws of indices can be written as this. But still there's no option written like this. So we apply some other laws of indices to get this. So we now have something that is in our option. The answer to this question is option B. So that's how to do the first one. It's pretty straightforward. Then now we go into the second one. Second question here is the problem 11, and it says we should factorize completely over the set of polynomials integral coefficient this. So this is a polynomial. X raised to the power 5 plus 3x raised to the power 4 minus 17x cubed minus x squared minus 3x plus 17. So usually when we have a polynomial, we usually try to look at this last term here. So 17, then we'll find factors of 17, that is plus or minus 1, plus or minus 17. I'll now try to check if 1 is a root of this polynomial, if minus 1 is a root, 17 is a root, or if minus 17 is a root. So that is the general way of trying to factorize polynomials. But there's something interesting about this particular polynomial we are given. So first of all, we should just try and notice the coefficients of the terms. So the coefficient of this first term is 1. Coefficient of the second term is 3. Coefficient of the third term is minus 17. Coefficient of the fourth one is minus 1. or the fifth one is minus 3, and or the sixth one is plus 17 or 17. So now if you notice 1, 3 minus 17, minus 1, minus 3 plus 17. Like these first three numbers, when you multiply the first number by negative 1, you get the fourth. When you multiply the third number by second number by negative 1, we get the fifth. And when we multiply the third number by negative 1, we get the last. So this observation is actually what helps us to factorize this. And also, you should notice like the powers are like successfully decreasing by 1. So those two occurrences will help us to get the factorization. So how do we do that? We just group these first 3 terms together. Later group these last 3 terms together. So when we group the first 3 terms together, what is common? X cubed is common. So we have x squared plus 3x minus 17. And this last 3, we can bring out minus 1. Have x squared plus 3x minus 17. This is just all we wanted. Terms in these both brackets are equal, so we can factor them out again. It's common terms. And we will have x cubed minus 1. So this is a factorization. And if we look at the options, yeah, we have seen our answer here. Option B looks like what we got. So the answer to this question is option B. But actually, this last term here, x cubed minus 1, it can be further factorized like using difference of 2 cubes. So x minus 1, x squared plus x plus 1. So this is like a much better factorization. Like this is the lowest possible like factorization you can have in real numbers. But we don't have this in our option, so we'll just like stick with what we arrived at here, and the answer to that is B. So we've been able to do the 2 questions. They were not really so difficult, but just still covered it today and keep on bringing out more contents. And this is all we have for today, and I'll see you in the next video.